right, so we're going to be checking out a presentation of Maya 2016 for the next hour. Thanks for taking time to joining us at the Autodesk booth this morning. So we're going to be looking at Maya 2016. It's a new release for us. We're announcing it today, actually this week at the show. Very excited about it. It's a massive release for us. And we're going to be covering off kind of the 8 high points that this release brings to the table. New look and feel, performance improvements, a new Delta Mush deformer, some sculpting tools. We'll be looking at improvements that were made to XGen. And then we're going to finish off with Bifrost. So there's lots of exciting things inside of Bifrost. We have a new foam model. We have a very art-directable guided simulation that we can do. And we also have an Aero solver. So we'll be covering off those 8 high points in the next hour, and we're going to be using assets from Hyperspace Madness, which is an internal production that we're doing that helps us test the software as we're building it. So there's lots of different artists and developers that are building these assets kind of scattered around the globe, and we're using Shotgun to manage the project. So you can see that we've had this project going for a little bit over a year now, and this is essentially where we're at today with the project. And what I'll do is show you a little early animation or a little pre-comp that we've done here of the actual assets that we'll be demoing with today. So this was rendered on the Amazon Web Cloud, which is really pretty cool. They helped us out a good bit getting these frames out because we were working on this right up to the last minute. So we rendered this on the cloud. We managed the job with Shotgun, and this is showing a few of the things that we'll be looking at today in Bifrost. So kind of those smoke trails that are coming off those laser blasts, all that water with the foam model on top of it, and then obviously some of the animation performance stuff that we want to talk about will be all based on this scene, which is shot 60 from the short that we've been working on. So let's jump into Maya really quickly, and we're going to start off discussing the new look and feel of the application. So 2016, the user interface has been completely overhauled. We've done lots of really nice things to the user interface to make it easier for both new artists to get into the tools and get up to speed quickly, but also help old artists that have been using Maya for a long time work more efficiently. So the new look and feel has the ability to scale based on the display device that you're displaying it on. So that means if you're working on a retina display or a very high resolution Ultra HD display, the icons will scale nicely, all the windows will scale nicely, the text will scale nicely, the marker menus, everything is tied into this scaling of the user interface, again, to make it work efficiently on high DPI or high pixel count monitors. You'll notice that if you've used Maya for a long time that it does look slightly different as far as the icons are concerned. We've gone to a flatter look when we were redoing those icons to make them scale, and we've also taken the time to color code them. So their color will give you a clue as to what the tool is going to do. So all the NURBS tools and NURBS curves tools are in one color, all the polygon tools and the new sculpting tools that work on polygons are another color, and then we have different colors for things like FX or FX caching. So new artists will quickly be able to say, hey, that's this color, I kind of know that's going to be doing this kind of class or this kind of operation. One final point, the user interface, we've also changed the menus as far as what they're filtered into. So we've always had the ability to filter out what this top menu bar has to be kind of task-based. And we've further refined that inside of Maya 2016. There's a lot of stuff that's been added into Maya over the years that was just put in kind of weird places and random places. So when we were redoing the user interface, we decided to kind of clean house and reorganize everything to be more task-focused. So what that means is if we jump into something like the rigging menu, all the tools that you need for rigging are going to be here. So skeleton tools, skinning tools, all the deformation tools, the constraints and control tools are all underneath the rigging menu. So that makes it much faster to work with because you're not jumping around the different menu structures to try to find things. It's also, again, going to help new users get up to speed quickly because there's a little bit more logic behind where the tools live. After 10 years, we just needed to kind of clean things up a bit. And that's what we've done in 2016. So the next thing that we're going to talk about with the new look and feel is some improvements that we've made to the Hypershade window. So I'm going to go ahead and bring up the Hypershade window as a floating window. Keep in mind that any window inside of Maya can be docked. It's based on Qt, so that's been around for a long time. But with the Hypershade window, we now have the ability to even go a step further by sub-docking things directly inside of this. So it allows you to create a very customizable look dev environment inside of the application. And you'll notice that there's a couple of things that are displayed here that if you're an old Maya you haven't seen before, an old Maya user, directly in the Hypershade window, we've now got the node editor. That's going to be your default mechanism for generating your graphs or your shader trees and things like that. It has tabs in there. So these tabs are actually saved with the scene. So if you've taken the time to lay out some big crazy shader and you've got it kind of organized exactly the way you want, leave that on a tab. Every time you close Maya and open it back up, that shader graph will stay preserved in that tab. So that really is actually super useful. You'll notice that we have this thing called Property Editor Material View. These are new inside of Maya 2016. Actually, I should take that back. Property Editor is a kind of a version of the Attribute Editor, but it gives us a more elegant way of interacting with it. So what does that mean in context? Well, if we go ahead and we grab something like this sand material, which is the ground plane here, In the property editor, you can see that the view is set to look dev. What that means is we're filtering out a bunch of stuff that you probably don't need to work with day to day. So this is going to, again, help old users work more efficiently because they're not trying to go through a bunch of sliders that they don't need to play with. It's also going to help new users into the application not get overwhelmed by everything that the attribute editor used to present to that user. And if you want to get back to what the attribute editor has, there is a button right there to just go ahead and click that. So you can see that a new user might be like, well, I'm going to expand all this stuff out, and what does all this stuff do? And I don't know, it just overwhelms me. So that's the idea with the property editor, is the ability to get down to this kind of filtered view that simplifies the interaction with the application. Another thing that's worth mentioning about the property editor is it has the ability to load multiple things into it at one time. So this makes working with it super fast, right? Like if I hold down my shift key and I just start clicking on stuff and adding it in here, you can see that I now get tabs that allow me to jump between all those objects that I've actually shift selected. So again, it's going to increase your productivity substantially inside of doing look dev work in this new Hypershade window. So the material view we have up here, you can see, obviously we have a shader ball. That's kind of nice that we have a bigger preview than we used to have. It's worth mentioning that this can work with multiple rendering engines. So right now we're looking at Maya hardware rendering. That's fine. I can switch this over to mental ray. It's going to now go through and do a ray trace, and it's going to get progressively more refined as that ray trace happens. You'll notice that we have the ability to, let's grab like a mental ray material, something that's got some reflection on there. We'll kind of shove that guy in there. So the lighting model inside of here is just using an area light. It's a big square light, so you can see that reflection of that area light in there. One of the things that's kind of fun about this is we can switch different presets for the material. So if I jump over to something like a shader ball, it's going to have some little fillets in there. So when I'm trying to fine-tune something like a car paint shader, doing it on that as opposed to just a simple sphere obviously is much better. So the other thing that we can do in this material view window that's kind of fun is we can put indirect illumination in there. We can put lighting probes in there and have that also contribute to the overall look and feel of that material as we're building it up. So I'll just do this exterior color 1, goes through, kind of puts it on a little parking lot or a little tile floor there. So we get all that nice secondary illumination, all that bounce light, and all those reflections showing up inside of there. And this is much faster to kind of build up your shaders and prototype your shaders than it would be to send an actual render off into mental ray from the full scene. So it gives us a fast way of prototyping what those materials are going to look like inside of the Hypershade window or the look dev environment that we now have. So the final thing that I want to talk to you about really quickly is the soloing workflow. So when you're building up complex shader environments and shader trees and things like that, often you're going to want to look at things isolated. What exactly is this this map contributing to the overall look of maybe another map, or maybe what's the bump map giving me without all the other lighting information included, or all the other texture information included. And we can now do that very efficiently inside of Maya because we have the ability to solo any node at any time. And it does different things based on the type of node that you're soloing. So let's walk you through that and show you what that means in context. So if we take something like this, this sand texture here and we solo that, well, what Maya is going to do is it's going to switch it over to a flat view in the material view here, and then you saw my viewport switch. The shading model on that object that's been assigned to is showing me just pure color. There's no lighting contribution added to this. So the shadows disappeared, all that diffuse lighting, all that contouring that happens disappears. So we get to see what that texture map looks like in its purest form. The other thing that's kind of cool about this is you can use this to really start adding in detail and seeing it in context. So if we go in here and we hit tab, and I just start typing fractal, just grab a 2D fractal inside of here. We'll get that guy in our scene. I want to use this fractal to start to break up that texture map a little bit. So what I'm going to do is I'm just going to take this guy, and we're going to drag this fractal into the color gain. So as soon as I do that, I can get a sense of what that looks like in real time. So I'm soloing this object, but I'm actually tweaking this object over here. And you can see how fast and easy I can use this to make versions or iterations of my scene, getting that isolated view of those two contributed maps using that soloing workflow. So very, very cool functionality. So the next thing that I want to talk about is, if we solo something like a bump map. Like if I go in here and solo the bump map, what Maya does is it does something slightly different. It puts the bump map into a mode where all you're going to be able to see is that bump on a white object. So it gives me the ability to remove all the diffuse lighting, all the diffuse map information, all the specular information. It lets me isolate that down to see what is that bump map doing on a pure white surface. So it both ray traces in the shader preview window, and it goes ahead and does a kind of a white material in the viewport 2.0 view. So that's a couple of the things that the Look Dev window brings to the table. The final thing that we want to talk about with this is some of the customizations that you can do to it. So it's very user configurable. It allows you to basically reconfigure it to work exactly the way you want. So if you look in the window tab here, you can see that I can start pulling other things out. I use my outliner all the time, so I'm going to pull that outliner out, and I'm going to dock it over here on that side. I also like to use my Create window. So I'm going to grab the Create tab. And what I'm going to do with that, guy, is instead of docking it, you can see how many places I can dock this. It goes anywhere you want. But if I drop it on top of the outliner, I now have a simple tab system that allows me to quickly switch between the outliner and my Create window. So something like this just gives you the ability to efficiently use that workspace, because I use that outliner all the time and that Create window all the time, but I don't want them both up at the same time. I don't ever really need them both at the same time. So having them shoved into these tabs just makes the use of this space, my screen space, very efficient and my workflow extremely quick. So the next thing we're going to talk about, we can close this guy down, is performance inside of Maya 2016. And this is probably the biggest feature, in my opinion, in the application, because almost every user is going to benefit from this. So up until Maya 2016, we didn't efficiently utilize all the resources that the computer had to offer. So in this example, we're running on an HP Z840. It's got a Quadro K6000 card on here. This is about as hardcore of a computer as you're going to get. It's got 20 physical cores running at 3.1 gigahertz. So we've got 40 threads running and a really high-end NVIDIA GPU on top of it. And Maya, in 2015, would only scratch the surface of tapping into those resources. In 2016, we can parallel evaluate your scene and efficiently set up the rigs so that they're going to thread really nicely. We're going to get concurrent execution on top of everything inside of Maya, which means it's just going to run fast. So let's check out what that means in context. What we've got here is Maya set up to evaluate in DG. That means legacy mode, Maya 2015 and before. And you can see that we're hitting around 3 frames a second. So not the best performance. The reason that it's not that fast is this rig that's on this character is actually super, super hardcore. It's like a crazy rig, right? If we grab this guy, it's an FKIK rig, and it's got squash and stretch on every limb, every node, every body part. So if I grab this arm and start to pull it, we get this really nice squash and stretch. Now to build this rig, the technical director had to use a ton of nodes, a ton of math, lots of crazy stuff going on. If we expand this out in our outliner and look at this guy, like we'll just expand this whole thing out here. We'll just say shift on that guy and expand it out. Look at all the nodes that go into making this rig up. You've got, hidden secondary skeletons, lots of different math going on to do that squash and stretch. It's just bananas, right? So that's why the rig doesn't play back fast, because it's just insane, right? So what happens when we go ahead and we turn on the parallel mode? Well, we're going to get a really big speed improvement. So the first step that we're going to do is turn on parallel and have it be just parallel without the GPU contribution. As I said before, we can utilize all the resources on the machine, both CPU and GPU. So certain things are going to scale really nicely on the GPU, things like skin deformers, blend shapes. So those objects, when we do our parallel evaluation, we can, if we decide to, send that information off to the GPU to be calculated. We're going to look at it all done on CPU first, just so you can see the kind of progression of the speed improvements that we get. So we went from 3 frames a second. We'll hit playback on this guy one more time. And we're now up to 8, 9, maybe sometimes 10 frames per second. That's a big speed improvement. Anytime you can double your speed with a button in an application, that's pretty cool. We're really excited about that. So what we're going to do is we're actually going to go ahead and look at this in the profiling tool to see how Maya is tapping into those resources. So if we go ahead and we say General Editors, Profiler, let's grab this guy up here. And we're going to go ahead and we're going to hit playback on this. So as it's playing back, I'm going to hit Start Record. So Maya's going to go through, record all that information, and you can see that I get a pretty good snapshot of how Maya's using this. And when I look at this profile, I'm like, okay, that's pretty cool. You can see that this is the evaluation of the rig. This is the draw of Viewport 2.0. So the rig's still taking more time to evaluate than Viewport 2.0. And with the parallel threading on there, you can see that I have a lot of densely packed data. But you can see these big bars here, right? What are these big bars showing me? Well, that's showing me what's slow in my scene. That big bar is saying it's his skin. This is a skin that's got open subdiv turned on, so we're using smoothing on top of this, and it's got creases. All those dark lines are creased edges. So I know that open subdiv can go on the GPU, and that's exactly what we want to do now. So let's see what happens to this rig and our frame rate once we go back into our system preferences and turn on the final stage of the parallel rig evaluation, which is the GPU component. So we'll put that GPU override on, and we can close this down. We'll save that guy off. We can deselect that, and we'll just play this back one more time. So with the GPU rig evaluation on, we're now up over 24 frames per second. As an animator, I work at 24 frames per second. I'm faster than that. I'm excited. I'm happy. Let's go ahead and go back and re-record this, and we'll just set this down to something like 10. We don't need to record quite quite so many frames there. So look at the data now when we look at this guy. Nicely, densely packed data. Here, I can just frame it on this guy. We'll just hit A on that guy. You can see that now the rig is evaluating almost as fast as the actual draw of the viewport. And the viewport takes some time to draw, right? Because I've got everything turned on in viewport 2.0. We've got shadows turned on. We've got insane amounts of textures in this scene. We've got really big geometry count, high polygon count. We've got depth of field on. We've got hardware-based fog on. We've got screen-based analysis on. So this is, we're getting this rich visual fidelity in our scene with all those things. And that's, if we go and we want to see how fast we can make it, if I just hit 5, and turn off the display of that stuff, we're now up to 60 frames per second. So that rig was playing back really slow before, without the crazy draw of viewport 2.0 with all those bells and whistles. That's fast. To make a rig that's got that level of sophistication play back that fast, that's just, it's crazy. I don't know how else to say it. It blows me away. It really does blow me away. All right, so let's go ahead and just finish this off by looking at the CPU view or the threaded view. And this is what you want to see. Right? If we start to scan through this, every single core on my machine is significantly contributing to the calculation of that file. So this concurrent execution of all the things in my scene happening at the same time is what's giving us that massive speed improvement. So the next thing that we want to talk about is the Delta Mush Deformer. And this is a pretty cool tool. This is something that the users have been asking for quite a while. And I'm going to jump over to another version of my guy here, and we're going to get our character back to the stance pose, his bind pose. And what we want to do is we want to go ahead and basically let the Delta Mush Deformer fix deformation artifacts. That's what it's all about. It allows you to quickly rig a character up. Say you've got a character, the model's not done, but the animator wants to get started. So you don't want the artist taking all the time to paint awesome skin weights on a model that's not completed. With the Delta Mush Deformer, we can do really bad skinning, let the Delta Mush Deformer fix it so the animator can get started, and then later on in the production, maybe we'll replace that skin with a high-res guy, and they'll go through and paint really nice weights. So the Delta Mush Deformer removes deformation artifacts, and what we're going to do is we're going to create a rig or a binding on this character that's just horrible, and see how good the Delta Mush Deformer can get at repairing probably the worst skinning job you're ever going to see. So I'm going to select my joints. I'm going to add to my selection my character's skin. We'll go up to the Deform menu and go to the Blend Shape. I'm sorry, we're going to go to Skinning and go to Bind Skin. And we'll put this down to a max influence of 1. And we'll set it to selected joints. So by setting that max influence to 1, essentially what I've done, let's just pop that OpenGL glitch there. What I've done is I've rigid bound those vertices. Every vertex is only exclusively parented into or related to one bone. So we're not going to have any weighting between, no nice mesh deformations in between those joints and transitions between those joints. So with that done, the next thing we're going to do is layer on top of this, while he's still in his bind pose, the Delta Mush, because I know I'm going to want to use that to fix some problems. And I'm going to turn off the envelope. I'm going to put that down to a value of 0 on that Delta Mush. Essentially, I've turned it off. I want to show you the bad job first, and then show you the improvements the Delta Mush brings to the table. So let's go ahead and jump back into our animation. And we'll just kind of start scrubbing through our time slider here. So as we scrub through this, look at under those arms. Look in this area. No nice deformations there. Just a mess. Garbage, right? Horrible, horrible skinning. But with that said, especially look at that. Look at all that craziness, right? That's not cool. With that said, because I have that Delta Mush Deformer on there, I can use this to fix the problem. So what the Delta Mush Deformer does, we'll just turn that onto a value of 1. You can see it fixed it up a little bit. It takes a smoothed version of your character, and it compares it to the reference version, the non-smoothed version, and it creates a delta between those differences, and it uses that delta to fix those problems. So if I want to see what that smooth version of my character looks like, and if we crank this up to 200, the higher I crank the iterations, the smoother it gets, the bigger the delta difference gets. If I start to drop down the displacement, this is adjusting how much those deltas are being applied. So that's the smooth version that we're generating those deltas from. And then obviously if I put the displacement back up to a value of 1, we're fully applying those deltas to do those corrective positions and those corrective shapes. So just look at that area right there. We'll turn the envelope back down to 0 so you can see what it looked like before. Look at this. Look at the back down here. Horrible, horrible skinning. Delta Mush goes through in, uses that smooth version to generate the deltas, and basically gives me pretty decent skinning that I can use to begin working with. So that's just a quick example of what Delta Mush brings to the table inside of Maya 2016. So the next thing, and it's also worth mentioning that those deltas and those frames that are recorded, you have access to those. So if you want to query that information and use it somewhere else along, or do something else with those deltas, they're actually available to you to be queried. So that's also a very important thing, that you can use this deformer to integrate into your own custom tools. So the next thing that we want to talk about is XGen, or actually sculpting. Let's do sculpting first. So let's jump over to this other version of my character here, and we can get rid of that delta skin. We don't need to see that. So we have a new sculpting tool set inside of Maya 2016. This tool set is actually based on the technology from Mudbox. So we have very high quality brushes. We'll just jump over to that shelf right here. And it's worth mentioning, these aren't designed to replace a dedicated sculpting system. It's not meant to replace Mudbox or even ZBrush in your pipeline, but it does bring some really awesome functionality directly into Maya, and because it's inside of Maya, you have some advantages. You can do things based on a shot, or based on the actual camera view, or you can use it in conjunction with other deformers. So it allows you to do some really nice modifications at the base mesh level, which is exactly what the tool is designed to do. So let's see that in context. We want to use this in conjunction with the blend shape workflow to start making some targets for our character. It's worth mentioning that we have made some slight modifications to the blend shape workflow, taking into account that we now have brush tools that can feed into it. So I'll show you that in context now. So I've got this piece of geometry that I want to create some targets on, or some blend shapes on. So we'll bring up that blend shape window, and you'll notice that there's no blends for our head. So we now have the ability to, even without any other geometry selected, just say, you know what, let's create a blend node on that currently selected mesh. So we create the blend node on there, and we now have this new button called Add Targets. So what I'm doing is I'm adding 4 sliders that we're going to paint 4 different blend shapes into, or 4 different morph targets into. It's worth mentioning that these targets that I've added are going to also be stored in the form of a delta. So that means we're only storing the difference between our base mesh and the deformed mesh that we've done with the brush tools. There's a couple of advantages of this. Number one, it makes your file sizes smaller. Imagine if that's a higher polygon head and it's a 10 meg file, right? If you had 10 blend shapes or 15 blend shapes in there, your file's now going to be 100 megs or 150 megs in legacy Maya. If we're only recording the deltas, the file size doesn't grow nearly as much. It's going to be very, very small, because the deltas are tiny compared to the polygons of the geometry. At any time, if you want true geometry out of that target, you can just click the rebuild blend shape from target, and it'll actually give you a true snapshot of that geometry. So it's a small little thing, but it's worth mentioning because it really will help your file I/O and your file sizes, the way we've kind of modified this tool to work a little bit better. So we're going to go ahead and we're going to start adding some paint information to this guy. I want to specify which slider I want that blend shape to get applied to. So we'll just hit the Edit button, and you'll see that Maya gives me a heads-up display saying whatever tweaks you make to this piece of geometry, they're going to get recorded in that slider's name. Pretty straightforward, right? So what we'll do is we'll go ahead and we'll grab our sculpting tool, and I can bring up the tool options for this by double-clicking on it. And anybody who's used Mudbox in the past, these tool options are going to look pretty familiar, especially if we start doing things like looking at the fall-off of the tip, or looking at the stamping option. So the stamping allows you to add a bitmap onto the brush, so it kind of roughs it up a little bit as you paint across the surface. That's because it really is the same kind of same high-quality brushes that we had in Mudbox, just inside of Maya now. So with that said, let's go ahead and look at a couple of the things as far as workflow with this. So if I right mouse click on top of my piece of geometry, I can turn on the display of the wireframe so we can see that as we start to sculpt. And you'll see things like steady stroke. What steady stroke does is it kind of averages out the normal, or the noise that my wrist might have. It gives me a tangent that I kind of follow along with the brush. So it makes painting things or tracing things a little bit easier, a little bit smoother. I can also really quickly turn on things like mirroring using my marker menu. So we're going to just give this guy a slightly stronger chin. We'll kind of paint across the bottom edge here, and we're in a simple pull brush right now, our sculpting brush. So I'm just going to kind of pull that stuff out at any time. At any time, if I wanted to do something like maybe turn off the mirroring now, I don't need to do that. Maybe I want to turn off that steady stroke. I want to push in a little cleft area in his chin here. If I hold my control key down, I get the inverse function, so I can kind of push that in. I might want to smooth those results out holding down my shift key. So a couple little hotkeys: shift, control, control, shift, give you some functions. Control shift actually goes into a relax mode. Relax is new. It's a new brush type in Maya. It's actually in Mudbox 2016 also, so that's kind of cool. So we've got that slider now that gives us that tweak or that modification. So let's go ahead and add another blend shape in here. We're going to go hit edit on that. And what we want to do with this one is we want to use the grab brush to sort of just lift his lip up a little bit. So if I right click on top of this guy and switch over to grab, I can pull his lip up here. And if I hold the control key when I'm in the grab brush, it actually gives me the new functionality of twisting or rotating around the middle point of my cursor. So again, I hold control, just kind of pull down or push up, and I can start to rotate that. That's also been added into Mudbox. So if we added something new in Maya, it also makes its way into Mudbox 2016 as far as the brushes are concerned. So the next thing that I want to do is I want to go in here and I want to lift one of these lips up. And this is kind of cool. So previously in Maya, if I'm using my grab brush, and we're going to do this on another blend shape here, I want to pull just the top lip up. When I grab that grab brush, it grabs the top and the bottom lip. That's because that grab is based around a volume by default. Maya has always had the ability to do surface-based fall-off. So what happens if we can combine that ability with a brush? Well, we can do some really awesome things. Let's go ahead and just say fall-off type, surface. So now you'll notice that my cursor is on top of the top lip, and it just grabs just that object. So it gives me the fall-off based around the parameterization of those polygons, as opposed to just grabbing a volume and grabbing both the top and the bottom. So little things like that make these brush tools super efficient inside of Maya 2016. So the next thing that I want to talk to you about is what happens when we start to sculpt in areas where you might have relationships between pieces of geometry. This is something that Maya can do, right? We can have those eyebrows be related to the underlying piece of geometry with a raptor former, and I've actually already got that set up. So this is really one of the advantages that having these base level sculpting tools in Maya brings to the table. So if I go and I use this grab brush to kind of pick this eyebrow up here, you can see as I do that, that eyebrow that's got that relationship to it goes along for the ride. So this is really what the sculpting tools and the sculpting workflow in 2016 is all about. So the next thing that we want to talk about is XGen. So XGen's had a lot of love in 2016, and I'm gonna walk you through some pretty cool new functionality that we've added into it right now. So let's jump over to another little version of my character here. We'll turn that hair off, and we can get back to our translate tool here and just select that. So I've got a scalp on my character, and I want to use XGen to generate some hair on this. So previously in Maya, I'd just be starting off from scratch, and I'd be, how do I make cool-looking hair? Well, what we've done in 2016 is we've included presets. So if we jump to the modeling menu structure, inside of, inside of modeling we have the create, and we're going to go to the XGen library. So what this does is it gives me some presets, and these may look familiar to anyone who's used Maya in the past. That's because what we did is we tried to make sure that if we could do it in Maya Fur, and Maya Fur had all of these presets, we want to be able to do the same exact look and feel in XGen. So we spent some time developing XGen descriptions that matched exactly the look and feel of the legacy Maya Fur. And this is great because it not only gives you a starting off point, but it gives you a really good tool to educate yourself into how to build your own descriptions, because in these presets, all the information to make those comes along. So all the modifiers, all the different ways that the expressions that might have been used, or all the noises that we might have been using, or the clumping that we're using, is all going to be embedded in that preset. So you can put it on something and go in there and kind of rip it apart and see how we did it. So it's a great educational tool for our users. So with that said, we'll just go ahead and we'll add onto this the line main, because I think it looks kind of funny. We'll just use the default options on the way that's going to get applied, and you can see in a matter of a few seconds, Maya builds that XGen description, and in Viewport 2.0, we get a very high quality display of what that looks like before we even go off to the software render. And that happened pretty quickly. It's worth mentioning that this is now threaded. So XGen in 2016 is threaded. That preview description, the generation of all those instance primitive hairs is threaded. It makes it much faster to work with, which just makes your day a little bit nicer, because it's so quick compared to what it was in 2015. Now, I don't really need line hair on my guy here, so we're gonna blow that away. I'll go over to the XGen window here and just grab that description and delete it. What I want to do is I want to get on some hair that I created earlier and I saved out. So this is another benefit of the presets. It makes it very easy for you to package up a look and take it from computer to computer or share it with other users. Previously in Maya, this was a little bit hard to do. Moving XGen around was not the easiest thing. The presets make that much simpler. So what we're going to do is we're going to go ahead and I've got some in here. You'll notice that these guys are color-coded. When you create XGen descriptions, there's different ways that you can make it. They could be based on expressions, guides, groomable splines, or archives, geometry archives. And that's what that color coding is showing me right here. And you can obviously filter that also. I want to use this Sven top spikes, so we'll double-click on that guy. This one's done with guides, so I need to make a decision on how do I want those guides to be applied. I'm going to use position-based, so we'll go ahead and we'll hit input on this. So the first thing you're going to see are those guides. That's the low-res guide curves that are used to control where the instance primitive splines go, which is what renders, like kind of dense instant primitive splines. So the workflow and the idea is you basically have low-res geometry, or low-res guide curves, positioning high-res instance splines. So what we're going to do is we're going to go ahead and look at a couple of the controls that this character's head has on here. So I remember I said before that in those previews, everything comes along for the ride. So you can see that to create this, we've got clumping, we've got subclumps that has slightly different parameters on there. Then we have a noise. It's got some expressions and some fractals kind of added onto that guy. And then we have a simple cut modifier. So all that comes along for the ride in that description. That's the key to the power of the descriptions. So what I want to do is I want to make some modifications or changes to these guide curves. And that's really fast and easy to do inside of Maya now. I'm going to turn off the display of our primitive splines, go in here and grab my control points, and just grab these guys right here. And previously in Maya, if I grab those points and I start moving them around, that was great. But often you don't want to move just a couple points on the end. You want to have a nice soft modification, have those points below it kind of come along for the ride. So in Maya, we have this soft mod tool. It's always been there, a soft transform tool. You hit it by hitting the B key. And up until 2016, if you did this with XGen, it didn't do anything. You couldn't move the points. They didn't talk to each other. It was a big limitation. So that's been addressed in this release. So now I just hit B, and you can see as I start to move that, the points below it have that kind of nice soft fall off of the influence of my current selection. So it's a very small change, but it has a massive impact on your ability to work efficiently with these guides inside of Maya. So another thing that we've done that's kind of cool is we've added in a new brush-based workflow for positioning those guides. So we now have this sculpt guides. So I can use this brush tool to just start pulling these guides around, maybe push them down a little bit more. I don't want those to be quite as high. So I can use this tool to generate modifications to those guides. And then obviously if we hit our preview button one more time, and again, that preview's fast, right? That would have taken 30 seconds, 35, 40 seconds in Maya 2015. Here it's done in like 2-3 seconds, much, much faster than it used to be. So that's a couple of examples of how we can use some of the improvements to the workflow for doing grooms on a character. The next thing I want to talk to you about is a couple little changes we made to, we'll kind of frame it on here, to the splines that allow us to do things beyond just hair with those primitive splines. I'm going to be using splines to actually make some alien vegetation that looks a little bit like these background kind of weird tubey things. So let's do that. So we're going to create a new description on our current selection. I'm going to tell it to be in a new collection. I don't want it to be in my character collection. I'm going to put it in my environment collection. So this is going to be an ENV collection. And I'm going to use splines again. We'll place those randomly across the surface, and we're going to be using expressions to control those. That's awesome. That's well and good. So that comes in and it creates these little tiny little tiny hairs essentially. I want to change my density down to something pretty low, and I'm going to make those hairs really tall, and I'm going to make them kind of wide. So what we've got now, right below the width parameter that I'm playing around with, you can see that we have this new width ramp. So this width ramp lets me essentially do a revolve. I can change the shape of this as it shoots down that spline. So let's just switch this over to spline interpolation. We'll kind of drop that guy down, do something like that, punk it up there, and then kind of drop it back down. So I'm trying to get something that looks a little bit like those back weird alien tubes. Maybe we'll jump over to the preview for this guy and crank that segment up to something like 10 or 20. So you can see that, before it could just do primitive splines, now we can change the shape down the length of those splines, so we can do things like make weird alien grass, or you wanted to do a feather, you could shape a feather and then flatten it out. Lots of different little things you could do with this spline tool now that we have that extra ramp modifier. So it was a small change, but it has a pretty big impact on the types of effects that you can get out of those instance primitive splines. I'll just add a little bit of randomness, or I'll just get a little bit of bend to these guys. Now, if I was really doing a production shot with this, I'd be jumping in here and I'd be saying, let's create some expressions to randomly change the U and randomly change the B, bend and things like that. But for this demo, we're going to keep moving forward. So the next thing I want to talk about is improvements that we've made to rendering and working with rendering with XGen and Mental Ray. So there's been some slight changes to this that actually have a pretty profound impact on your workflow. So let's check that out in context. We'll jump over to our Hypershade window here. And what I want to do is just graph the material associated with this guy. We can go down to a hardware preview for this. So I've got these descriptions in here. Here's my environment description. If we just kind of do something like that, you can see that this now has this new physical hair material. This is something that we really needed to get, was a really nice hair shading model. Now, obviously for alien tube grass, I don't want a hair shading model on there, so we're going to get rid of that and just put a standard Maya material on there. The standard Maya materials now render inside of on XGen inside of Mental Ray, so that's a big help. So you'll see I'm using this new look dev environment to do that. How quickly it is for me to work by jumping back and forth between my create window and my outline window and not having them take up a ton of user interface, I can really quickly go in here and select that object, assign that material to it. Awesome workflow. I'm going to double click on this guy and I'm going to add a ramp in here. So the ramps always showed up in the viewport with XGen, something like that. Maybe we'll go in here and we'll make this go to from that black to like this weird kind of alien bluey green whatever color, something like that. And maybe we'll go in here and add a little bit of noise onto that guy. We'll just put a little bit of value noise on there and kind of try to match those background guys a little bit. We could always do that, right? It would show up in the viewport. The problem is when you do a software render with this, it didn't translate. So we now have a couple of XGen kind of utility nodes that allow us to get this information into XGen. So this is a VRAMP. VRAMPs inside, ramps in Maya are great workhorses, right? Because you can change what is the feeder of that V value. So right now it's a placement node, a UV placement node. What we're going to do is we're going to blow that UV placement node away and say, you know what? We want the length of each one of those splines to feed that ramp. And we can do that because we now have this new XGen length mapping. So if I just type XG inside of here, it filters that guy out. So you can see these are the new XGen utility nodes. So we're going to grab the length mapping, and we'll just grab this guy. And instead of having a UV texture editor drive that V value of that ramp, I'm going to just have the length mapping of each spline drive it. So by doing that simple hookup, this will now render in software. Small little change, big impact on your day. So that's pretty much it for XGen. Oh, it's also saving your presets. Let me just show you that because it's super simple, right? I just say, I want to export this out as a preset, my current description. So I say export preset. It brings up my little browser here. I can take a snapshot of my window. And just like that, I say export, give it a name. I'll just leave it at its default name. That will now be available to me every time I open up Maya. If I want to grab that and share it with a friend, put it on the internet, I'm done. Just like that, I've created an alien grass preset for XGen. So the next thing that we're going to jump into and start talking about is all the really cool stuff inside of Bifrost. We've got 20 minutes to get through this, so I'm going to be moving pretty quickly. Bifrost has had a lot of improvements in 2016. Really, really cool stuff. And we're going to actually be using this version of Maya to start talking about the first one, which is foam. So what I have loaded up here and what we're looking at is a Bifrost liquid simulation. Bifrost is representing this in our viewport in the form of flip particles. So you can kind of see the kind of little bit of waves going through there. And I've got this kind of splash happening here. And I want to layer on top of this, and I'm just going to change the size of those particles a little bit so that they're a little easier for you guys to see. So we'll jump into our waves. We'll go to that wave shape, and I'm just going to increase the size of those guys a little bit and maybe jump down here and play around with that color remapping ever so slightly so that you can get a sense of where those waves are kind of moving. So it's a little bit clearer as to the movement of those waves. So we want to layer on top of this some foam. And we now can do that because we can emit foam, another set of particles, foam particles, based on that liquid simulation. So let's go ahead and see that happen. We'll jump in here. We'll grab our Bifrost liquid. We'll go up to foam, and we'll just say create foam. So Maya's going to go through. It's basically figuring out this frame, and we're going to get a couple little dots popping on in just a second. Let's just rewind you guys right here. So that foam kind of kicks in there. You can see those little white dots that just kicked in here. We have this new Bifrost foam added to it. The foam is going to have its own set of parameters that we can use to adjust in the viewport. So I'll make those guys a little bit bigger. So those are the foam particles that got kicked on. Now I'm going to start changing some of these attributes to make that foam a little bit more prevalent. So let's check that out. We'll jump over to our liquid container. We'll go into the new foam section inside of here. So I'm first going to increase my emission rate. We'll double it. So we'll put that up to a value of 2,000. The next thing that I'm going to do is I'm going to change my min speed down to a value of 0.1, and my liquid churn, which is sort of the, in this example, it's going to be the turbulence. And if you had something with like a lot of swirl or vorticity, like the propeller of a boat or something in the water, it would be the liquid churn that you'd be using to adjust how many bubbles or how much foam would get kicked out of that. So we're going to put that value down also to something like 0.5, pretty low, and we'll just re-simulate that. So we cache this out, and you can see that in just a few seconds, Maya's going to generate foam that's a bit more dense in the areas of high turbulence and speed. So we're starting to get a lot of foam on that misty splash that's happening. Some more foam happening where these rocks are kind of kicking in here and hitting the collisions happening. It's kicking off more foam. It's also worth mentioning that the foam actually has the ability to generate on the surface and below the surface. And the way that foam dissipates or propagates is going to be different based on whether it's above the liquid or below the liquid. So you have individual controls for if they're in the air or if they're in the water. So it gives you a lot of flexibility to get different looks from this foam. So I'm going to just go down to that foam one more time, or go to that Bifrost container one more time, And I'm going to drop down that liquid churn a little bit lower, and I'm going to change the curvature down a little bit too. So we'll put this down to 0.2, and I'm going to put that curvature down to 0.1. So the curvature is how steep is the wave. If it's a very steep wave, the water's going to fall fast. You'd expect it to create more foam. So with that done, I'm going to jump back out to my desktop, and we're going to be using RV to, actually desktop, let's go to that guy. We're going to be using RV to go ahead and flip a couple of objects, or a couple QuickTime movies here. So RV is the newest addition to the M&E family. It's an amazing player. It can play, obviously, QuickTime movies and MPEGs and things like that. But it also flips EXR files, EXR sequences. It lets you do compare and contrast. Awesome, awesome tool with lots and lots of functionality. We're just going to be using it to flip our animations here to show you a couple wedge tests. So what I've got is actually, we're going to do that in just a second. This was the reference that, by the way, that we were trying to, we used for the rock. So this is what we were thinking about when we said, let's do a rock with some water and some crazy foam. So you can see how misty that foam gets and how these waves look. So that was sort of some reference footage that we had. Let's jump back into Maya and see what that foam looks like if we recache that guy out. So you can see we have a ton of foam. And that foam calculation takes some time, right? And for certain shots, you might need to calculate the foam over your whole scene. Bifrost actually has a lot of areas where it can be adaptive. It doesn't need to think about things outside of certain regions, and that makes it very, very fast and efficient to work with. The foam model has a component to it that is adaptive. We can make it adaptive to the camera. So what does that mean? Well, it means I don't have to emit particles where we're not going to see them, where they're outside of the view of the camera that might be rendering. So let's check that out. I've already got a camera in my scene here, and I just want to make a couple connections from that camera into my liquid sim. So that's the camera, and you can see that's the camera frustrum. And what we're going to do is we're going to grab that camera, and we're going to grab our liquid shape, and we're going to make a connection. We're just going to say Bifrost adaptive camera. So by doing that, and we'll turn the clip on here, we've now basically told Bifrost only emit particles inside the frustrum of that camera. That means my calculation times are going to be much faster. It's going to have the ability to generate the particles really only where we need them, which is very, very cool. So hopefully this will calculate out here in just a second. You can see we now have Bifrost particles, foam particles, only living in the region of that camera. And what that means to the sim times is really pretty significant. So we'll jump back to that desktop, and we'll bring up the movies, and I'm just going to flip this wedge test of the adaptive foam attribute. So we'll go ahead and flip that guy. So what we've got here is the camera panning across the beach. This is the shot that we actually end up rendering. And you can see that our sim time without the camera adaptivity turned on was almost 6 hours. And then we get it down here to the lowest value, which is sort of down here in the lower right. We've cut it down to 3 hours, or I'm sorry, the lowest value is the one directly next to it. So it goes from almost 6 to 2.5, and then as we start to introduce more foam, that value, the lower the value gets, the more foam gets generated, the easier it is for it to exceed that threshold, the more foam you get. So as we get a little bit more foam, we're up to 3.5 hours. This is the one we actually ended up rendering was right here. And then you can see as that kind of comes in and it hits that rock, you get that really big kind of splash that happens there. And that's all done with that foam particle. So let's check out what the finished frames look like rendered. So this is all done on this kind of weird alien planet that Hyperspace Madness shot lives in. So the water's like this kind of acidy blue, thick, weird alien water. I guess it's not really like the water we have on Earth. It's kind of a acid water, I think is what the art director referred to it as. But you can see all those Bifrost foam particles. They ride on top of that surface. They kind of are underneath that surface. They show up in the refraction of it, the reflection of it, and then there's that big splash of all those foam particles coming out over top of that rock. So that's what Bifrost foam is all about in 2016. So let's keep moving forward here and talk about the new guided workflow. So the guided workflow is really cool because it allows you to art direct liquid simulations, and it gives you a lot of control over how the sim's going to work. The idea is that you can take a low-res sim or an animated piece of geometry and have that guide or influence a high-res sim. So the high-res sim gives you all the subtle details and splashes on top of the low-res movement. Very, very powerful functionality. So in this example, we're going to be using an animated piece of geometry to generate the guide or influence the overall liquid simulation. So I'm going to build this up from scratch. We'll start off by creating. We'll go to the FX menu, which is where all dynamics lives. And we'll go, Bifrost isn't in there, so we'll load the plugin really quickly. Just going to scroll down here and make sure Bifrost is loaded. There we go. We like Bifrost. Let's make sure you're in there. All right, so we're going to go ahead and create a liquid from this. So once we recreate that liquid, what Maya does is it generates flip particles in the whole volume of that piece of geometry. That's not really ideal. With the guided simulation, we can have that emission happen only on the top surface. This allows us to work with higher resolutions, get faster sim times, and smaller cache sizes, all good things. So let's see how we set that up. What we're going to be doing is we're going to use the same piece of geometry that we emitted from as our guide shape. So we'll say add that in as a guide. The next thing that we want to do is just add in a collision object or a pool to hold this information. So we'll go in here, and I've got a piece of geometry in my scene, so we'll grab both of those guys. We're going to go to Bifrost and add that in as a collider, and then we can hide that. We don't really need to see that anymore. The final thing that we're going to do is jump over to our attributes for this Bifrost container, and we're going to add into this, we don't need spatial adaptivity. That's something else, but we can talk about that maybe later. What we're going to do is we're going to go ahead and just make sure we go down to the guided sim section and enable it. So now that we've done that, if we rewind this, it'll basically go through and calculate those particles only on the top surface. So we've got everything hooked up. I actually want those to dive down a little bit deeper. So I'm going to change my min depth down slightly to a value of 2 instead of a value of 3. So this is going to make those flip particles adhere to that guided shape a little bit more. So now that we've done that, let's go ahead and just modify a few attributes before we send this out. So since we've got this guy here already selected, I'm going to also add a foam model on top of it. That's kind of cool. We'll jump back into this Bifrost liquid shape. I'll increase the size of those points a little bit, and we'll rewind this just so you can see what's going on here. And I'm going to change the color so it's not that default blue. We'll just kind of match it to our scene. So the liquid shape is really my mechanism for adjusting the representation of this Bifrost data in the viewport. That's really what this does. So we're going to go in here to our color, and let's just change that from that bright color to something that's like a little bit more similar, and we'll drop that threshold down that lets us see the movement of it a little bit better, down to something like 15. So with that done, what I'm going to do is I'm going to highlight this. We're going to make sure Bifrost is set to cache to the background, and it is. So what we're going to be doing is we're going to be sending this information off to Bifrost to calculate that dynamic simulation. Bifrost lives outside of Maya, so it receives that data. We're sending frames to Bifrost to think about. That's what's happening right here. That next bar that's updating over there, that's the computed data being sent back into Maya in the form of a scratch cache. So we can see how quickly that liquid sim starts to adhere to that piece of geometry. That guide shape immediately starts taking those particles and moving them around. And you can see that we're getting that little foam model on top of there, and we're getting all that subtle detail from that high-res sim happening underneath that low-res deformation that's kind of guiding it. So let's check out a couple of examples of what that min depth looks like, because the min depth really is one of the attributes as an artist you're going to be tweaking and tuning to adjust how much of that guided sim comes through into your final simulation. So let's go ahead and look at a wedge test of that. So we'll just flip the min depth one, again using RV to do this. So what we've got here is it's a few different examples of different guides. So this is using a small min depth of a value of 1. You can see that there's a little subtle splash happening here, but for most part, we're really just getting the look and feel of that piece of geometry with a little subtle detail on top of it. The deeper we go, the more dynamic it gets, the crazier it gets. So we can start to see more splashes and little extra sim stuff kind of happening on top of that when we get to a value of 1.5. Right over here, we're up to a value of 2. It starts to get kind of crazy, and then by over here, when we're going really deep at a value of 3, you can see that dynamic information is really just throwing that wave over. We're getting a lot of white water, a lot of splash. So you can use that min depth parameter to really fine-tune how much extra chaos do you want in your environment or in your liquid simulation. So super duper cool. So let's see what this looks like when we render it out. So I'll just show you the end result, and in this, it's a slightly different version. What we're doing is we're animating the waves on, and then we're animating the waves off. So in the foreground, it's all guided simulation. The background's actual geometry. It's the same geometry that we used to guide our liquid in the foreground. And you'll see a pretty clear line where when the white water kicks on. So again, that foam model has thresholds. Once the waves get kind of crazy, the foam will kick on. You'll start to see a little bit of foam, and as they get larger, the thresholds are going to get exceeded more. There's going to be more foam. So guided sim, geometry in the background, and they really do match each other. You can see how art directable that was. We took deforming animated geometry basically and have it do this liquid simulation in the foreground, and we get all that subtle sub detail from that dynamic sim layered on top, which is really, really cool. Very fast, very efficient workflow. So the next thing that we're going to talk about and finish up off with is the Aero model inside of Bifrost. So this one's actually really quite exciting. Let's go ahead and jump back into our scene here. You'll notice that my viewport is set to use OpenGL Core Profile. This is new in 2016. Core Profile runs on all platforms, so OS X, Linux, and Windows. And what Core Profile does is it makes OpenGL be able to achieve a lot of the really cool effects that DX11 could do. Obviously, DX11 being a Microsoft property only runs on Windows, so like hardware-based tessellation on the GPU, all those really crazy game shaders. Mac guys running Maya and Linux users couldn't really start doing all these really cool real-time shaders because OpenGL didn't support that. OpenGL Core brings all that functionality into it, so it's very, very cool. And we're using this to actually do some voxel rendering in the viewport on Bifrost. That's why we're in OpenGL Core mode now. So I'm going to just blow away this liquid sim. We don't need that in our scene. And I don't need that camera in there anymore either. What we want to do is we want to use Bifrost to generate some atmospheric effects using the new Aero solver. So the Aero solver has a couple of advantages over classic Maya fluids. It works in a massive computational domain, big, huge spaces. The Maya legacy fluids would choke at that. It's very high quality, and it's much faster to work with. So there's lots of reasons why you want to use the Aero solver to do your gaseous atmospheric effects inside of Maya now. So what we're going to do is we're going to create some particle or some aerosol particles from this crazy spaceship that kind of comes in here and starts blasting our hero character, right? So that's what we want to do is we want to get some kind of trippy, wispy trails behind those laser blasts. So this is really fast to do in 2016. We're going to go ahead and we're going to grab our objects that we want to have be emitters, which are just some little animated spheres, have a little bit of noise on them, so it's going to make that emission have a little bit of randomness to it. And I'm going to set my start frame up to 870 here. Make it a little bit easier. So we want to take those guys and we want to have those be part of the Aero solve. So by having them selected, when I create that arrow, they're automatically added in as emitters. So the next thing that we're going to do is we're going to add in some collisions to this guy. I want the blast to hit that rock in the background. So we're just going to add to our selection a couple pieces of geometry, go to Bifrost, and create the collider. So now that we've got the collider created, we're going to go to the attributes for this Bifrost Aero container and change a few of the attributes. So the first one that I need to do is change the start frame to where those guys start emitting frame 880. The next thing that we're going to play around with is the voxel size. So the master voxel size and the render voxel factor are very important. So the Aero solver is it's a flip solver, right, just like Bifrost. And the master voxel size is setting the resolution of our simulated space, our solve, essentially, for those flip particles. On top of that, we have render particles, and they can have a different resolution. So the idea, very much like Guided, where you could have low-res sims driving high-res data, the Aero solver has the same type of functionality where we can have a low-res flip simulation advecting its information onto high-res render particles or transporting its movement onto those high-res render particles. So it makes it very fast and efficient to work for. We're going to leave this kind of at its, we'll make the voxel size a little bit smaller, but we're not going to play with the render factor quite yet because I want to show you what this looks like at the default values. So we do that. We'll go ahead and we'll rewind this guy. And let's just make sure that Bifrost is set to background compute. It is, so we'll hit go on this guy. So you can see Maya comes through. It starts to send that information to Bifrost. Again, it's calculated outside of Maya, and it starts to send in some frames here. So what we're looking at are the actual render particles. By default, what Viewport 2.0 shows us is the render particles. And you can see that they look kind of cool, but there's a little bit of stepping there. So I mentioned before that Bifrost has the ability to be adaptive in lots of areas. The time stepping can be adaptive. So this means it can be smart. If it's moving really fast, we want to have more steps. If it's moving slow, we want to have less steps. Less steps is obviously faster to calculate. So the fact that it's adaptive is super cool. So we're going to put the min step to 2, and we're going to put this value to something like 0.5 to make it a little bit more prone to kicking in. I'm also going to take the time to make the threshold a little bit lower in the smoke. This is where the gas exists, so it's going to be a little bit longer before it kind of dissipates out. And we'll just replay this now with these slight modifications. So you'll see that what we're going to get now is a little bit better stepping. We're going to have just a small little trail of flip particles or render particles kind of coming across here. Now, anytime if I want to see what's going on with my flip particles, I can jump into that Bifrost Aero shape node. So the shape node, again, is the node that allows me to adjust the Bifrost data in the viewport. So we can do something like increase the point size of those guys a little bit. And at any time, if I want to see, do some diagnostics of what's going on with my sim, I can switch some stuff around here. So I can go to the component display and say, don't show me the render particles, show me the flip particles. So those are the particles that are being used to generate the movement. Now that looks really blocky and coarse. That's not actually showing us the kind of resolution of those flip particles. If I wanted to see that, I can just switch back to my render particles and go to my tile view. And the tile view gives me the ability to really see how that Bifrost Aero solver is voxelizing the environment. So you can see the areas where it needs more detail. We have denser tiles, and we can focus in on that by using this fall off command. So I can really start to fine tune and say, you know what, show me only the highest level. And we're at level 7. What we're seeing is the actual master voxel size. So that's the resolution of my dynamic simulation. Now, as I said before, we can take this flipped particle simulation and vect its information onto higher density render particles or higher detail render particles. So let's see that in context. What does that mean? Well, this is with the default values. If we jump back to the Bifrost Aero container and we go to that master voxel factor and we start to modify this, this is what sets the master voxel factor with the master voxel size is what affects the render voxel size. It's a multiplier. So if I multiply the render factor, put it to a value of 0.5, we're going to be cutting it in half. The voxel size for the flip particles is going to be 0.05. If we cut it in half, for the render particles, their resolution is going to be 0.025. So my render particles now have twice the resolution as my simulation particles. I'm also going to jump down here to my particle density, and I'm going to increase the particle density. I want more render particles than simulation particles. So we're going to have 3 times as many render particles as we have sim particles, and we have twice the resolution. So we're not really changing the sim at all. We're changing the look of the render particles that, that they're getting the information vected onto. That's all we're doing. So the sim is exactly the same. The render particle look is going to be different. And I'll play this back, and you'll see that it's pretty amazing the difference that we get here. So we'll just let this kind of cache out. And we're going to finish off looking at 2 things. I'm going to run a minute over. They're going to have to forgive me because Gary Davis before me doing his 3D Studio Max demo had so much to talk about. He ran into my time, so I'm going to run into the next guy's time, so I apologize for that. But I got to show you this stuff because it's so cool. So what we've got here is obviously a pretty different looking sim. Keep in mind, when we had that render particle stuff set to the default values, they looked a lot different. The sim is the same. The data that's driving those render particles hasn't changed. The last thing that we want to talk about super quick is the ability to visualize what a volume render would look like. So particles are great, but when we're going to render smoke effects, a lot of times we want to do a volume render. So we can actually see that in Viewport 2.0. If we go to the Aero shape, instead of having the particles on, we're going to put the voxels on. And I'm going to jump over to the new Aero material. So we'll go to the Bifrost Aero material. I'm just going to crank this up pretty high for demo purposes, and we'll increase the intensity of our shadows, and that sub-absorption will let the light get absorbed a bit more. So in Viewport 2.0, I get this really beautiful representation of what that render would look like, that volume render would look like, before we even commit to doing software rendering. So that's pretty amazing. So I'm going to finish off just flipping a couple more movies. So again, this is what the comp looks like where we're at. This is obviously still very much a work in progress, but this shows a lot of that atmospheric of aero effects happening, the Bifrost liquid happening, there's blasts coming in. There's actually a really cool little rock explosion there. That rock explosion is very subtle in this movie. If you actually look at this version, this was the raw render before it was toned down in the comp, but it gives you a good sense of what that aero solver can do. I mean, to get that detail in legacy fluid solver would be very, very hard to do. It would take forever, and it happens extremely quickly here. So those are a few things that are new in Maya 2016. We saw the new look and feel, the hypershade window, performance animation, amazing, the Delta Mush deformer, sculpting tools, XGen, foam, Aero, guided, all that stuff inside of Bifrost, amazing stuff. If you want more information, please go over to the leads desk, have them scan your card, or come talk to me. I'd love to chat with you about Maya. Thanks again, everybody, for checking out Maya 2016.